If you check the sticker price of a Boeing B-17 Flying Fortress in 1945, you will find a number that looks surprisingly affordable. $238,129. In the modern world, where a single Ferrari SF90 costs over $500,000, buying a 4-engine heavy bomber for less than the price of a suburban house seems like a joke. Even if you adjust that number for standard inflation, it comes out to roughly $4.2 million in 2025. That sounds incredibly cheap. For comparison, a modern B-21 Raider bomber costs nearly $700 million per unit. A single F-35 fighter jet costs around $80 million. So how did the United States build the most complex weapon of its time for pennies on the dollar? The answer lies in a misunderstanding of cost. The price tag of $238,000 was not the real cost of the weapon. It was a receipt for the metal and the assembly. It did not include the research, the factories built from scratch, the government-subsidized aluminum, or the most expensive component of all, the 10 men inside. Today, we are going to audit the B-17. We are going to strip away the paint and look at the economics of strategic bombing. We will analyze how Boeing achieved a 70% reduction in costs through mass production, why the bombsight cost more than the pilot's entire lifetime earnings, and why the true cost of delivering a bomb to Berlin was actually measured in billions, not thousands. To understand the price of the B-17, we first have to look at the learning curve. This is a fundamental concept in industrial economics. When Boeing built the first series of B-17s in 1939, they were handcrafted machines. Every rivet was placed by an artisan. The cost of a single B-17B model in 1939 was approximately $300,000. Adjusted for inflation, that is nearly $6.5 million. But by 1945, despite the plane getting heavier, more armed, and more complex, the unit cost dropped to $180,000 for the final G models produced by Douglas and Vega. That is a 40% reduction in price during a period of high inflation. How did they do it? They stopped building planes and started manufacturing units. The B-17 was broken down into sub-assemblies. The wings were built in one factory, the fuselage in another, and the tail in a third. They didn't come together until the final moments. This allowed Boeing to use unskilled labor, often women who had never seen an airplane before, to perform repetitive, specific tasks. This is where the economics of the B-17 diverge from modern military tech. Today, we build small numbers of highly complex machines. In WWII, the US strategy was to turn the B-17 into a commodity, like a Ford Model T. Let's break down the components. What were you actually paying for? The airframe itself, the aluminum skin, the ribs, the spars, accounted for about 60% of the cost. But aluminum in 1940 was a strategic metal. The price was artificially controlled by the US government. If Boeing had to buy aluminum on a free market, the B-17 would have cost double. The government built the smelters, subsidized the electricity for the refining process, and guaranteed the supply. This is a hidden subsidy that never appears on the $238,000 receipt. Then there were the engines. The B-17 used 4 Wright R-1820 Cyclone engines. Each engine cost roughly $10,000 in 1942. That is $40,000 just for the power plant, nearly 20% of the total cost of the plane. These engines were marvels of mass production, but they were also disposable items. A Cyclone engine was rated for a certain number of hours, but in combat, they were often run at maximum power, overheating and degrading much faster. The economic life cycle of a bomber engine was weeks, not years. But the most surprising line item on the invoice was a small box in the nose, the Norden Bombsight. This analog computer was the secret weapon of the US Army Air Forces. It used gyroscopes and gears to calculate the trajectory of a bomb. In 1940, a single Norden Bombsight cost $6,000. To put that in perspective, the average annual salary of an American worker in 1940 was $1,300. The bombsight cost 5 times more than what a worker earned in a year. In today's money, that is an $80,000 laptop sitting in the nose of the plane. It was so valuable and so secret that crews were required to take an oath to protect it with their lives, and it had to be removed from the plane and locked in a safe after every mission. Now let's talk about the guns. A fully equipped B-17G bristled with 13 50 caliber M2 Browning machine guns. Each gun cost roughly $700. The total defensive armament cost about $9,000. But the guns are useless without ammunition. A standard loadout was around 5,000 rounds of 50 caliber ammo. At 25 cents per round, that's another $1,150 every time the plane takes off. This brings us to the operational economics. Buying the plane is the cheap part. Flying it is where the money burns. A B-17 carried 2,800 gallons of high-octane aviation fuel. This wasn't standard gasoline, it was highly refined 100-octane fuel that required complex chemical engineering. In 1944, aviation fuel cost the government about 15 cents per gallon. That means a single fill-up cost $420. That sounds cheap, right? But you have to factor in the logistics. That fuel had to be shipped from Texas to New Jersey, loaded onto a tanker, sailed across the Atlantic through U-boat-infested waters, offloaded in Liverpool, and trucked to an airfield in East Anglia. By the time that gallon of gas reached the B-17's tank, its delivered cost was nearly 10 times higher. The U.S. Army didn't just pay for the fuel. They paid for the convoy, the destroyer escorts, and the sunken tankers that never made it. Now we arrive at the most expensive component of the B-17, the crew. We often think of conscript soldiers as cheap labor. A sergeant gunner earned about $100 a month. A lieutenant pilot earned roughly $200. On the payroll, the crew cost less than the spark plugs. But this ignores the capital investment of training. To train a B-17 pilot required hundreds of hours of flight time, burning thousands of gallons of fuel, and using trainer aircraft like the T-6 Texan. The Army Air Forces estimated that it cost $50,000 to train a single pilot to combat readiness. A B-17 had 2 pilots, a navigator, and a bombardier, 4 officers, plus 6 enlisted gunners. The total investment in human capital inside one B-17 was roughly $250,000. Think about that. The training cost of the 10 men inside the plane was higher than the cost of the machine itself. When a B-17 was shot down, the loss of the aluminum was negligible to the U.S. economy. Boeing could build a new plane in a few days, but the loss of the crew was a financial and strategic catastrophe. You cannot mass-produce experienced pilots on an assembly line. This economic reality dictated the strategy. The U.S. could afford to lose planes. They could not afford to lose crews. This is why the B-17 was designed the way it was: heavy, slow, but incredibly durable. The engineering priority was crew survival, not just because of morality, but because of economics. Let's scale this up to the fleet level. The U.S. built 12,731 B-17s. The total procurement cost was roughly $3 billion in 1945 money. Adjusted for inflation, that is about $50 billion today. That seems like a bargain for a fleet that destroyed the German industry. But we must look at the depreciation rate. In the 8th Air Force, the depreciation rate was terrifying. In 1943, the life expectancy of a B-17 bomber was just 11 missions. The statistical average said that a plane would be turned into scrap metal before it could even require an oil change. During the famous Schweinfurt-Regensburg mission in August 1943, the U.S. lost 60 bombers. That is $14 million of equipment, in 1943 values, vaporized in a single afternoon. In today's money, that is a loss of nearly $250 million in a few hours. If you ran an airline and lost 15% of your fleet every time you flew, you would be bankrupt by Tuesday. But the war economy operates on different principles. The return on investment wasn't profit. It was the destruction of enemy assets. Did the B-17 pay for itself? This is a controversial economic question. A B-17 might drop 4,000 pounds of bombs on a German ball-bearing factory. The bombs themselves were cheap, basically steel casings filled with TNT. A 500-pound bomb cost about $100. The payload cost less than the fuel used to deliver it. However, the accuracy was poor. In 1943, Only about 20% of bombs fell within 1,000 feet of the target. This meant you needed to send 500 bombers to ensure one factory was destroyed. So the economic equation is not one plane versus one factory. It is 500 planes plus 5,000 crewmen plus 1 million gallons of fuel, one factory. When you do that math, the cost of destroying a single German target was astronomical. It cost the United States billions of dollars to cripple the German oil industry. But here is the final economic twist. It was worth it. Why? Because the cost to Germany was higher. When a B-17 dropped a bomb on a synthetic oil plant, it didn't just destroy a building. It forced Germany to divert thousands of 80mm anti-aircraft guns to defend the Reich. Those were guns that could have been killing Soviet tanks at Kursk. It forced Germany to keep hundreds of fighter planes in the West. It forced them to rebuild factories underground. The B-17 was an economic attrition machine. Its job was to force the enemy to spend money they didn't have, to fix problems they couldn't solve. The US economy was the only one in the world that could afford the B-17. The British couldn't afford to build a fleet of that size by themselves. The Germans certainly couldn't. The Soviet Union didn't even try. They focused on tactical ground support because it was cheaper and more immediate. Only the United States, with its massive distance from the front lines and its unlimited natural resources, could afford the luxury of a strategic heavy bomber fleet. The B-17 was the ultimate symbol of American wealth. It was a weapon that said, "We have so much money, so much aluminum and so much fuel that we can afford to fly heavy machinery over your house and drop money on you until you give up." So, how much did a B-17 actually cost? If you look at the receipt, it cost $238,129. But if you look at the system required to keep it in the air, the training, the fuel, the escorts, the bases, and the inevitable replacement of losses, the cost of maintaining a single B-17 in combat for 1 year was closer to $1 million in 1944 currency. That is roughly $17 million today, and the US had thousands of them. The paradox of the B-17 is that it was cheap to buy but expensive to lose. Yet, the US built them faster than the Germans could shoot them down. In the end, the economics of mass production defeated the economics of precision engineering. The B-17 wasn't the best plane of the war, but it was the most economically decisive one. It proved that in an industrial war, the side with the deepest pockets and the most efficient assembly lines usually wins. So, here is the question for the comments. Knowing the astronomical cost of the crews compared to the planes, was the US policy of daylight precision bombing an economic mistake? Should they have switched to night bombing like the British to save the expensive human capital? Let me know your analysis below. And if you want to understand how the other side tried to fight back, check out our video on the economics of the German V-2 rocket, a weapon that cost more than the Manhattan Project but couldn't hit a barn.